Hey guys, today we're doing absolute value inequalities. And this, for some odd reason, has proven to be quite a challenge. And when we do this in Algebra 2, at a little bit more of a difficult level, of course, it always creates huge confusion. Okay, so what I recommend that we do here, and I give them the same rules that I'm giving you, but I think that they know better and they don't have to write them down. So, having said that, here are the rules that we are going to follow to solve absolute value inequalities. When we have a conjunction, remember what that is, less than or equal to, also means that we are sharing a solution, okay? And that is going to help us remember these rules. We're sharing solutions or overlapping them. Remember that, okay? From our conjunction and disjunction sections, okay? Conjunction means that we are sharing or overlapping the solutions. So when we remove the absolute value symbols from an absolute value inequality, we are going to take the argument, okay? And the argument is going to be greater than the negative. So say I've got a negative number right here and less than the positive, okay? So if I've got greater than the negative, I'm going to the right of the negative. If I've got less than the positive, I'm going to the left of the positive. And what you see here is the overlapping, and that is the conjunction, okay? So if an absolute value, just for example, if an absolute value looks like this, that is a conjunction, okay? And then we'll solve these as we get to that part of the lesson. But a conjunction means that as long as you have an overlap of your solutions, that means that you've gone greater than the negative, which is to the right, less than the positive, which is to the left, and you get that overlapping area. For a disjunction, remember, you've got the union of everything on the number line, everything together on the number line, joined with the word or. Okay, so when you're looking at a disjunction absolute value inequality, you've got a greater than symbol. So this is a disjunction while the other one is a conjunction because of the symbol. So the first thing that we're going to have to do when we approach these problems is look at the symbol and which one are we dealing with, the conjunction or the disjunction. Okay, so in a disjunction, the argument is going to be less than the negative and greater than the positive. And remember, a disjunction, one of the ways that we were able to represent a disjunction was in that formatting, where, of course, there is nothing joined here, nothing overlapping, but there doesn't have to be in a disjunction. That is a classic disjunction graph right there. One value goes one way, the other one goes the other way, and they keep traveling far in opposite directions, okay? So that is the rules. I highly suggest that you write them down, and when we write them down, then we'll utilize them as we go through the examples. All right, so for example 1, we have that the absolute value of x is greater than 1. Okay, so we have a disjunction because of the symbol. So we are going to go less than the negative. So less than the negative and greater than the positive. Okay, so less than the negative and greater than the positive. All right, so we remove the x from the absolute values and we set the argument less than -1 and then greater than positive 1. So negative 1, positive 1, less than negative 1 goes to the left, open circle, because it's greater than and not greater than or equal to. And then greater than positive 1 goes off to the right. Okay? And then we could do the same thing with, use the absolute value of x is less than 1. Okay? They use the absolute value of x is less than or equal to 4. Let's do the absolute value of x is less than or equal to 1. All right. First thing, look at the sign. It's a conjunction. So I know that I'm going to be greater. Let me write it a different way. Maybe it'll make it easier to understand. Greater than negative, less than positive. That's the rule for conjunction. Okay. So we remove the x from the absolute value symbol, and we're going to set it greater than or equal to negative 1 and less than or equal to positive 1. So negative 1, positive 1, greater than or equal to negative 1 goes this way, less than or equal to positive 1 is going to go this way. Okay, and you see you've got your joined area of solutions right there where they overlap. Okay, so very basic way to start these problems. All right, example 2. We have the absolute value of x plus 5, and we'll do a couple of these. The absolute value of x plus 5 less than or equal to 10. Okay, this is a conjunction. This is a conjunction, so we're going to be greater than the negative and less than the positive. Okay, so remove the argument from the symbol and set x plus 5 greater than or equal to negative 10 and x plus 5 less than or equal to positive 10. And we'll solve this now as we were a regular inequality or equation. Subtract 5 from both sides, and you get that x is greater than or equal to negative 15. Okay, and the joining word, remember the joining word for a conjunction is and, which is also this symbol right here. Okay, then if we subtract 5 from both sides in the other inequality, we get that x is less than or equal to positive 5. And we're going to graph the solution set just to make sure that this is, in fact, a conjunction, that the solutions overlap. So greater than or equal to negative 15 and less than or equal to 5. Okay, so we could do, let's say, this one is from the homework. Number 10, we have the absolute value of 3x minus 10 is less than 9. Okay, this is also a conjunction. So the argument is going to be greater than negative 9 and less than positive 9. So we'll add 10 to both sides, and we'll get that 3x is greater than 1, and x is greater than 1/3. Okay? Likewise, we'll add 10 to both sides to get that 3x is less than 19, and x is less than 19/3. Okay? So graphing the solution set. Obviously, even though we don't know the exact value of 19/3, you don't need to know it to know that it's bigger than 1/3. Okay? So 1/3 is to the left of 19/3. You need to make sure that you're putting your critical numbers on the number line in the right order or the whole thing is going to be obviously epically wrong. Okay, couldn't get any wronger. All right, so x is greater than 1/3, goes to the right, open circle, and less than 19/3, open circle, and all the way to the left. Okay? Okay. Now, example 3, we have a disjunction. Negative 3x plus 6 greater than 18. That is a disjunction. So will be less than the negative and greater than the positive. Okay? So remove the argument from the absolute value symbols and follow my instructions, okay? Less than negative 18, and then negative 3x plus 6 is greater than positive 18. And we'll solve each one of these individually. We'll subtract 6 from both sides here to get that negative 3x is less than negative 24. And we'll divide both sides by negative 3. So remember what we do when we have a negative coefficient. We switch the way that the sign is. Okay? So instead of a less than, it is now a greater than. X is greater than 8. Coming over to the other inequality, we'll subtract 6 from both sides there as well and get negative 3x is greater than 12. And again, we're going to divide both sides by a negative number, x on the left, negative 4 on the right, and the sign changes direction. So when we graph that disjunction, negative 4 is to the left of 8, and we are greater than 8, open circle, to the right, and less than negative 4, open circle, and to the left. Let's do another one of those. Let's do 2x plus 6 is greater than or equal to 14. Okay, first thing, disjunction, because it's a greater than. Disjunction means less than the negative, greater than the positive. Okay, so 2x plus 6 less than negative 14, and 2x plus 6, less than or equal to, and 2x plus 6 greater than or equal to positive 14. Okay, subtract 6 from both sides, and we get that 2x is less than or equal to negative 20, and x is less than or equal to negative 10. Likewise, subtract 6 from both sides and get that 2x is greater than or equal to 8, and x is greater than or equal to 4. Okay, so negative 10 and 4 less than or equal to, closed hole over the negative 10 and to the left, closed hole over the positive 4 and to the right. Okay? So, hopefully that makes some sense. Now, the last thing is the story problem. It says most human muscle cells function well within 2 degrees. Within 2 degrees. That is a very important expression right there. Very important statement. Within 2 degrees of their optimal temperature of 98.6. So we need to write that as an absolute value inequality. So if we are, if we're talking about within 2 degrees, it can be from -2 to +2. So our temperature can be inside greater than -2 and less than -2. That's what within 2 degrees means. It can be 2 degrees colder or 2 degrees warmer. Well, when I look at the way that that is written out, I can see that that's a conjunction, okay? So I'm going to say T for temperature instead of X. So remember, always an absolute value has a standard form of X minus. This time it's a T, but same thing. And we're looking at less than or equal to, because it can be 2 degrees higher or lower inclusive, okay? So we are within that 2 degrees, okay? Because of the -2 and the +2, that's our range. And then our midpoint, remember, is what goes inside the absolute value, which is 98.6. So in words, what this says is that the temperature is plus or minus 2 degrees of 98.6. And that's simplifying it, but that's exactly what the wording in the example says, okay? So now that we've got the absolute value inequality, knowing that this is a conjunction, we are going to be greater than the negative and less than the positive. So these are the allowable values for the temperature, okay? T minus 98.6 less than +2. And I'm going to erase that just to get that out of the way, okay? And then we'll add 98.6 to get that T is greater than 96.6 and T is less than, 98, 99, 100.6, right? So as long as we are greater than 96.6 or less than 100.6, we are within 2 degrees of that midpoint. And we can even check this. 98.6 is, in fact, the midpoint between 96.6 and 100.6. And the way that you can find that mathematically is to add the two endpoints together, 96.6 plus 100.6. And then, of course, once you get that sum, divide it in half, and you get your midpoint, 98.6, okay? So within 2 degrees to the right and 2 degrees to the left. And notice that's exactly what we solved for. Okay, just remember these rules. And I'm going to change colors. So basically, if you want to shorten down the rules and just use a couple of different symbols, remember that the conjunction is greater than the negative and less than the positive. And the disjunction is going to be less than the negative and greater than the positive. Okay, so just remember those, and that will help you get through absolute value inequalities. All right. Pretty good, guys. See ya.